We're going to revisit our 4 kinds of argument declaration and passing, and talk about a couple of common gotchas. I'm going to revisit zip with some of the new power that we've got, and then spend some time figuring out how namespaces and scoping works in Python, which we've just kind of waved our hands about so far and not really examined particularly well. And then we're going to talk about the fact that functions are first-class variables in Python and what that lets us do. We'll get into reading and writing files a little bit, parsing the command line a little bit, doc tests a little bit, start to tour some of the standard library, and we'll just continue to develop our classmates file to explore all that. And if we're lucky and we progress well today, we'll get into some sorting with higher order functions, and maybe do like anonymous functions and closures by the end of the day, if we can get there. So that's our ambitious plan. So let's go ahead and review what we know about functions. OK, so we declare functions with a def keyword. We give our function some kind of name, hopefully a more meaningful one than that. And what are the ways in which we can specify the parameters the function will accept? What do you mean by designate parameters? OK, and what are those kind of parameters called? Positional parameters. And they're also mandatory. If I specify parameters like that, a and b, this is a function that takes 2 arguments. And woe betide you if you only pass it 1. Right? So positional, mandatory arguments. How else, somebody else, how else can we define parameters to our functions?
You can assign a default value if it's not provided.
OK, yeah, we can assign a default value. And we are also implicitly giving this argument a name. These are named and optional function arguments, function parameters. And we can now call this function and only pass it 1 argument if we want to. Now, I lied terribly yesterday in the interest of simplification. And this, as long as we're clear on how this works so far, this shouldn't blow your minds too badly. We can mix and match these 2 things, right? We can also call any parameter, no matter how it's defined in the function, either by name or positionally. That's calling, that's not defining. So if you notice there on line 5, I said a equals 2. That first parameter is a positional parameter, so I wouldn't have had to specify the name. And it doesn't specify a default value, but I still could specify the name. How you call the function is not dependent upon how the function was defined in this sense. There's some limitations to that, obviously. The other thing is I could make them both be positional parameters. Right? So the second one, when I define the function, has a name and a default value. And I didn't specify the default value. I just passed a value. And you can see this in section 7.2. And I have it underlined in my much marked up printout. But any argument to a function can be passed implicitly by position or explicitly by name, regardless of whether or not it has a default value defined in the function. So our only limitations for that are, when we're calling, all the positional parameters have to come before named parameters. And the reason for that is I can call named parameters in any order that I want. But the order of positional parameters is kind of crucial. So line 7, I called my function foo with b equal to 4 and a equal to 2. They're both named. I called them in backwards order from how it's defined. But you notice it still printed out a first, printed out 2 and 4. It printed out a and then b. It still knew which value went to which parameter because I explicitly named them. In line 8, I specifically named the value for 4, and then I just passed a positional parameter, and it doesn't know what to do with that. Is that the first positional parameter, because there haven't been any before, or is that the second, because it's actually the second? It's too confusing. You can't figure that out. So all your positional parameters have to be first, and then any name parameters. Does that seem clear to everybody? So there's a huge gotcha with defining default values, and it has to do with how Python parses your code. And I'm going to type in the example from 7.3. And actually, you go ahead and type in the example from 7.3 and run it as well. Does it know the order?
Yeah.
It doesn't, because in that case, there would be no positional parameters.
Okay.
And OK, so I should say before we jump to mutable arguments, that's the other little wrinkle we had yesterday, right? When you define your function, there's two other ways you can define your parameters. Remember those? New pieces of syntax, star and star star. And the names are actually not significant, but the convention is always to use args and keyword args. What does that function do? Any if I can type here, it'll print any positional arguments, because it specified star args is the array of all the positional arguments that are handed to the function. And I just gave it a keyword-based argument, and it doesn't accept any keyword-based arguments. Similarly, what does that do? Right, so star star keyword args indicates that my function accepts an unlimited number of named arguments, whatever their names are, and it's printing them. And if I pass positional arguments in this case, it complains. And we can mix and match and we can mix and match our arguments that we pass to it, and it'll accept both. You don't often see a function that defines itself with both star args and star star keyword args, because it doesn't really tell you anything about what arguments that function accepts. But you'll very frequently see a function that looks like something like that. So if I had a function that is going to move a polygon around, you have to pass it the top left position of the polygon. But then you could define how you're going to move it in a variety of flexible ways. Like you might decide to move it based on its relative position or its absolute position, or based on its top left position, or based on its middle. And you could define all that in your keyword arguments. Leave some flexibility, but you've got a couple of mandatory arguments that must be accepted. So that's a more common mix and match style. OK, so that's everything we covered yesterday, I think, on functions. Now for the gotchas. From section 7.3, and I'll do a simpler version here. OK, so what does this function do? And it accepts b, which is a keyword argument that has a default value of an empty list. Right? So I might pass b something, and if not, it should be an empty list. And that works out as you expect, right? It printed an empty list the first time when I didn't supply a default value. What if I change b inside my function? OK, did what I expected. Now what's it doing? It's remembering the status of the list from function call to function call, which is not the behavior I thought I was going to get. And the takeaway from this is Python is allocating the default values at function declaration time. When the function is defined, it creates a default list and assigns it as the default value for b, name parameter b. And that is a mutable variable, and we're changing that mutable variable inside the function. Each time you run the function, it's not recreating the default values. It's using the same default value that it used when it defined the function. So this is remembering the same value for each run of the function. And there are times when that behavior is useful, but 99% of the time, that catches you off guard. That isn't what you expected. You thought you were just saying, hey, I want an empty list by default, or you can pass me some stuff. If you made it a tuple, it's immutable.
So whatever you did to it.
And you can't do anything to it. You can parse it, print it, iterate through it, but you can't change it. If you want a mutable variable as a default value, and you don't want it to remember its state from time to time, how would you do that? Ideas? Yeah, you'd have to declare it inside the function.
Because this is what this means is that the parameters which you are passing into the function are becoming like a global variables, right? Because
The parameter is not, but the default value is. Nope, outside the function, there is no b. B did not become a global variable. But what happens is, what happens when Python allocates a variable? It looks at the type, whether it's mutable or immutable. It makes space for that type on the stack, and it assigns a label to it.
Okay.
And that label is only visible in context of the function.
Of this particular function or any other?
Of this particular function. Yep, has a whole different namespace.
That has another variable like a b.
It's a different b.
Is a different
No
b.
relationship whatsoever. Yep.
Only for this particular series.
And we're going to clarify scoping and namespace rules in a bit, but it works as you would expect, at least the naive approach, which is each function has its own local namespace, and its parameters are visible only within the function's own local namespace. And it doesn't remember if there isn't any default value, because it gets the value from each function call. The twist here is the default value is calculated when the function is defined, and each successive run uses the same default value.
74 values. 74 values that you specify.
That you specify.
Is part of the input parameters, right?
Yes, that is part of the function definition. And that normally doesn't screw you up when you say default is true or default is 1. They're immutable. And strings are immutable, so you don't see it there. Lists are mutable, and it's pretty common to say, oh, let's default to an empty list. And if you want to do that, you need to do this instead. Let's see if this actually works. And here we're getting the behavior that we expected. So our default value is none, which is immutable. And we say, hey, do we have the default value? So presumably the user did not pass us something. And if we do, then let's go ahead and initialize an empty list. And since that empty list is run every time the function is run, it works as we would expect. So this is one gotcha with the default value implementation of Python that will bite you at some point. I've stumbled on this myself, even though I know it. I'm just explaining it now, so when you screw up, you'll understand why you screwed up later on. And let's go ahead and look at the closely related concept of calling functions. Now that we understand how to define them, and I think we've covered everything about how to define them and their parameters. We're going to talk a bit today about functions as first-class objects in Python, which they are. So in lots of languages, functions are kind of, they're a little weird compared to other things. For instance, PHP back there. PHP lets you refer to functions by name as strings. At least it used to, but there was no way to actually say this variable is a function. It did a lookup on a name based in your namespace table.
One last question.
Yes, totally. As long as what you're initializing them to is immutable, then you're fine. If what you're initializing them to is a mutable variable, then you need to do the pattern we just specified there on line 28, where you use immutable value as some sort of flag. And you could say, and you could use something else. You could say b equals -1, and then if b equals -1 inside the function, go ahead and initialize it to the mutable thing that you wanted. Yeah.
I want to pass the parameters to that.
So you still could pass, like with foo that we have there, I still could pass. Presumably what you want to do is pass it a list. And it works like we would expect. That list went to...
If you call this to a function again and see what happens?
Say again?
If you call this function again, would you create another tab? Oh, okay.
No, because what we did is we said the default value is none. And if the default value is none, make it an empty list. Well, in this case, the default value would not be none because it's getting the value I passed, which is a list 1, 2, 3. And in that case, it doesn't run this code. It just appends A to B and prints A and B. So it's a little guard to check your calling condition. And you have to, basically, you have to use immutable values for your default parameters unless you know what you're doing and actually want to have essentially a function counter. OK, so the related concept of calling functions. Functions are first-class objects. Other languages like C lets you have function pointers, but there's some special syntax around that I distinctly recall screwing up a few times. In Python, a function is just a variable like anything else. If I type foo, I see the value of my function. It is an object of type function, and it runs ID on it. Just like if I type x as a string and evaluate x, I see the value of my variable. A string value obviously has a nicer representation than a function value, and Python does not by default show you the source code for your function. There are ways of getting at it, but it is actually sort of a semi-compiled language, so your source isn't readily available for inspection. But you can see that it's just a regular function, and we've been calling functions by appending parentheses. And in this context, parentheses are the operator to call a function, to call any callable, which we'll talk about some more later. And what that means is I could say, now what's x? Yes, it will. And functions are immutable data types, so you can see that the ID is the same. They're pointing at the same function. And yes, if I append the callable operator to the end of my variable, it calls the same function. So functions could be passed to other functions. Functions can be assigned to variables. Functions could be stored in data types like lists and dicts. If you want to have a list of functions to apply, there isn't any special syntax for that. Just list your functions in a regular list. There is some special syntax for calling functions, and it is what you would expect. We've seen two cases so far. So how did I call, what did I do with my parameters? What's the first parameter 1 here? It's a positional parameter. It's just a value. There's no name associated with it, and it's going to go into whatever parameter was first in my function. And this is, it's a named parameter. I could have left it off if I wanted to. I'm specifying a value. And that's completely, it's related to how the function is defined. But remember that it's not linked, because I could name both of them. And I could pass both of them positionally. So it's the same syntax for passing name parameters and positional parameters as it is for defining them, but the one thing does not depend on the other. Right? You can have a function that has all positional arguments, and you could name all the arguments when you called it if you wanted to. Make sense? So the last trick is the star args and star star keyword args works when calling as well as when defining functions. So how about this? And again, the name is totally insignificant. Just convention is to use args. So args is a list. The first position is the number 1. The second position is an empty list. And I could say foo star args. What is the implications of star args? How is my parameter handling working? What is Python doing? What kind of parameters?
Positional ones should be, right?
Totally. So I have a list. A list is a positionally based container. And Python unpacks my list and uses each item in my list as a positional parameter. So the first item on my list is the first positional parameter to the function. The second item is the question, Trenton.
So you're not defining the function.
I am not defining the function. I am calling the function. And star args works when calling as well as when defining. And again, it's independent of how the function was defined. I did not define my function with star args. My function does not accept an arbitrary list of positional arguments. It accepts one positional argument and one optional keyword argument. But I just called it with 2 positional arguments. And the same rules apply you can't do that. My function takes 2 arguments, not an arbitrary list of arguments. And when I called it with star args in a list that had 3 items, it says, I'm sorry, you gave us 3 arguments and we only take 2 arguments. It is unpacking the values for me and calling the function as though I'd explicitly called it with 3 arguments. Make sense to everybody? And of course, we can do this too. So what's going on? What does calling foo star star keyword args make Python do? So it's using the labels in the dict as the names of the function's parameters and the values as the corresponding value. And that foo star star keyword args is totally the same thing as that's literally what it translated out to. Python unpacked my dictionary, used the name and value pairs to call my function with named arguments. And again, my function does not accept any arbitrary dict of keyword arguments. It accepts 2 arguments. One is a positional argument named A. The second one is a optional labeled argument named B. And if I pass it a dict that has a label C, it says I don't know what this argument C is. So if I say foo keyword args, I called the function with one thing, which is a dictionary, which it printed. and then appended to the second argument, which is the default value b. It can't tell that I want to unpack the dictionary. If it unpacked every dictionary it got, or it unpacked every list that it got, you could never call a function and pass it a list. So star and star star is special syntax to indicate unpacking of the arguments contained in this complex type, or acceptance of arguments in a complex type. And again, it's related. The syntax is the same. You're doing the same sorts of things, but you can call a function with star args or star star keyword args, regardless of whether the function itself was defined with star args or star star keyword args. They do different things in the calling context versus the defining context. 2 stars unpacks a dictionary into keyword arguments. 1 star unpacks a list into positional arguments. And when you define a function, 1 star says I accept an arbitrary number of positional arguments, and 2 stars I accept an arbitrary number of named arguments. And yesterday, we were using, some of you at least, were tackling the unique roles in your classmates. And I was suggesting that we use zip to do it. And then when you start coding it, you see that you have to pass to zip. And I'll cheat here and just make myself a list of tuples. We wanted the unique list of instructors, and I was saying you could use the list and zip and sets to extract that. But zip, I should do it non-IPythonically. Zip takes multiple arguments, where each argument is a row. So I could get what I wanted, but I had to hard code each of those arguments. And that returns me the 2 columns, first names and instructors. And I could refer to the instructors list, and now I have all the roles. And then I could convert it to a set, and I have just the unique roles. But I had to hard code, because I'm calling a function and passing it parameters. Zip will take an arbitrary number of parameters, and I might not know how many parameters, how many rows are in my list. So how can I call zip passing it all the rows in my list without hard coding them? Everybody see why that works? Classmates is a list. Each item in it is a row. When I say star classmates, it unpacks each item in the list and treats it as a positional parameter to zip. So this zip star classmates is exactly the same thing as this zip classmates row 0, classmates row 1, classmates row 2, but it'll handle however many rows I have, which is kind of typical when we're programming. We don't know in advance how large our data set is going to be. And so it's nice to be able to call functions and pass them an arbitrary number of parameters. So our question from yesterday about unique roles could break down to that. Zip all my classmate rows, give me the index into the columns that corresponds to instructor. You had 3 tuples, most of you, so that would be 2 instead of 1. Make it a set, which throws away the duplicates, and convert it back to a list. And yes, you're right and perceptive. That looks a lot like Lisp code, especially all the catch-up parentheses at the end. Anybody unclear on that? Thinking about that? OK, in that case, let's talk a little bit about scope and namespaces. And once we've covered this, which should take us about 10 minutes, I'm going to go ahead and turn you loose on the lab I was putting up yesterday, and I'll go ahead and put up the instructions again. And after the break, we're going to talk a little bit about higher order functions, or functions as first-class citizens to start out with, and have you redo, hopefully, what you can implement before the break. So, scope. Scope is really important to keep in mind. It's basically a question of what variables can I see at any time. We already have some tools to investigate and manage our scope. What tools do we have so far? How can I figure out what variables I can see? Yeah, so locals is a built-in function. And it shows all the variables that I've defined down there at the bottom. Plus there's some more that IPython supplies. How about globals? There's even more. So there's two namespaces available to us at any one time. Our local namespace and our global namespace. Right now, I'm not inside of a function. So my global namespace and my local namespace are the same. But we create new local namespaces by doing lots of different things in Python. A few less things than some other languages. There's an example, 7.6, in your book that notes some languages have block scope. So in C, for instance, if you make a for loop and you have brackets and you define a counter variable, that counter variable is only in scope for the enclosing brackets of the for loop. If you tried referring to it after the body of the loop, there would be no such variable. C has a new namespace for that multi-line statement. Python does not. Python creates new local namespaces only on functions, modules, and classes. Not quite true, but I'll lie again for simplification purposes. So our functions, if I define a function, good old foo is getting a workout here. And it prints locals versus looking at locals outside the function. They're dramatically different things, right? Yeah, so how about this? What's going to happen when I call foo? It does. Oh, x is not in the local namespace of the function. So how does the function see x? Python follows lookup rules when it encounters a variable. It looks first in the local namespace. There's some other rules if you're inside classes and objects. If you're inside a function, it looks first in the local namespace, and then the global namespace, and then it gives up. Well, built-ins are sort of a special case. How about this? What will I get? Don't those two examples seem like they're contradicting each other? In the first one, we printed a variable that was in the global namespace. We could see it just fine. In the second one, we assigned 4 to that variable in the global namespace, and then we print it after the function is run, and it's unchanged. So Python handles one case differently, and the reason is because it's a dynamic language. There is no variable declaration in Python in general. So variable declaration happens on assignment. So line 76, when I say x equals 4, Python looks in the local namespace for a variable named x. If there isn't one, it creates a new variable and assigns it the value of 4. It does not proceed out to the global namespace to do a lookup when it does assignment, because it assumes you're doing the common case, which is creating a local variable in your function. There's a local namespace for modules, a local namespace for functions, and then when we get to classes, there's also a namespace associated with classes. Yes, so you pass in variables that would be in the local namespace with parameters. If I pass parameters to this function, as function accepted parameters, they'd be in the local namespace.
Okay.
Any other variables in the local namespace are created by assignment, because that's how we declare a variable in Python. We just put a value, put a label on a value.
The globals at the top level.
And at the top level of the same thing.
Same thing.
So at the top level, when we do variable assignment, it creates a new variable in our local namespace, which is also the global namespace.
So
There isn't if you're in the top namespace, if you're not inside of a function, if you're not inside of something that's created a new local namespace, local and global are the same namespace.
Okay.
There's no new namespace created. And technically, when I'm running inside of a script like this, the global namespace is actually the module namespace. And each separate module has its own namespace. But we'll see how that works when we get to modules and packages.
So from the programmer's perspective, I don't have to worry about
It's global variables all the way.
global variables, local variables. I just need to look at the local variables, or just one
Yes.
variable will be good enough.
Yes. It's
Okay.
sort of a special case when you think about global variables. So inside of a function, if you reference a variable that you have not yet created, it will go back and check and see if there is such a variable in the global namespace. And only if there isn't will you then get an error that, hey, this variable doesn't exist. And that can sometimes lead to obscure bugs. All bugs, depending upon globals, are obscure.
When you import a module, it imports to your module namespace. It's equivalent to your global.
Excellent question. And when you import a module, you don't import its namespace. You create one new variable that points to that module. And hold that question, because I'll be right back to that.
So what you're saying is that if you import a module, you only have the module names in the global variable list.
Nope. Hold that question. I'll be right back to that. OK, so I have a function foo. If my input parameter is equal to letter A, then it assigns x is 1 and prints 1. And that works. If it's something else, I get an error. My input parameter was not A, and therefore x was never created. And it's not a scoping issue. It's an issue of code execution path. The x equals 1 statement never executed, so there is no local variable named x. But if I had done this beforehand, and actually I take it back, it's a little bit smarter than that. I just noticed the error message. By the rules that I've described, x should work. It should print the global variable because it does a lookup in the local namespace. Python checks for you, and it's basically for your sanity. It notices that there is a local variable x in this function, but that I'm printing it without it being assigned to, and it doesn't even bother to go out to the global namespace. And it's kind of a good thing that it doesn't, because the execution of this function then would be dependent upon global variables, which is usually a bad thing, unless you're explicitly looking for that. OK, so your question, and we're not quite to packages and modules. We will be, but it's a good question because we're thinking about namespaces. What happens when you import a module to your namespace? Do you get all the globals of that module in your? And you don't. It's really nice. Python is extremely hygienic by default. When I say import datetime, what changes have occurred? I have one new variable in my local namespace, which, because I'm at the top level, is also my global namespace. That one new variable is of type module. And that variable contains the module namespace. Everything that's defined in that module is only accessible through the module. There is a way to be unhygienic. We'll get to it, but it's usually a bad idea. So yes, Python slightly alleviates the dangers of global variables in that very frequently you're working with modules and packages, and at least your global variables are only global to your own module. They're not global to the entire program scope. And that's not true of all programming languages. OK, so yeah, let's answer that question. What if I want to change a global variable inside my function? I can't, right? Because when I say x is equal to 5 inside my function, it makes a new local variable instead. Is that going to work? What exactly is occurring on this line? Am I initializing a variable? Is there assignment going on? Nobody wants to hazard a guess. Hey, it's 50-50. I'm not creating a new variable here. I am referencing a variable and making assignment to its member. Since it's mutable, I don't create a new local variable x. And in fact, that's the wrong syntax. If I tried to create a dictionary that way that didn't exist, I get an error. I'm accessing, not creating a variable. And that's legal. This variable happens to be a mutable one, so I can change its contents. But I'm not putting a new name, a new tag on anything. So if you want to change something in the global scope, one way to do it is access a global mutable variable and change its contents. Yes, I could do assignment positionally or append something to it. There's one other rule that's sort of a shortcut for this, and I think it's it's the global statement. And global indicates to Python to reach out into the global namespace upon assignment. So if you don't want to be creating a local variable that shadows the global namespace, you have to explicitly say, my function is going to reach out into the global namespace and change it. Your function has side effects. We don't like side effects in general. In general, we don't want to use the global declaration, but it's possible. OK, let's go ahead and tackle a little bit of a lab. And I've got a couple new Python idioms to show you. This is kind of what I put up on the screen yesterday in case anybody was bored as of 4 o'clock and was ready to do something different. So the last thing that we had done successfully, and hopefully everybody's got to this point. If you haven't, I'm going to circulate around. We talked about zip and getting the unique role of, or the unique list of roles. It's not necessarily necessary that you complete that. And we're going to throw that little piece of work away. It was mostly to set you up to see the beauty of star args, argument passing, and their usefulness. But you should have a classmates.py that defines a function print record and defines a function get record, and you're able to solicit input and add it to your dict. Output, check and see if the user's input was a valid first name. And starting from that position, we're going to modify how our program works. And we're going to do a couple different things. One is a really common Python idiom that you should use in all your scripts from now on. And here's how it works. Python defines a bunch of global variables for us automatically. And the special ones start with underscores. Wrong one here. We'll get to special methods that start with 2 underscores, but there's a bunch of special variables that start with 2 underscores. In general, the presence of 2 underscores indicates some kind of provided or special function or data type. This is name underscore underscore name underscore underscore, and you'll hear it referred to as a dunderscore variable or a dunderscore method. It's ugly to type and look at. And in general, it's to sensitize us that we're doing something slightly unusual. Python automatically sets the dunderscore name variable with the context of the currently running program. So let's see how that works a little bit. I have a script, and all my script is going to do is print name. OK, it printed name. Name is equal to main. I'm going to enter the Python command line. I can import my script by specifying its name. I do not specify the .py extension, and it's part of why it's important that you name your Python scripts ending in .py. This gives me a variable, scripting, but that output line there is the result of my script running. It's printing the name variable, and now it says scripting. Before it said main. The context in which my script is running in this case is as a module, and it's given the module name to the name variable. The context in which my script is running now is not as a module. It's being run as a top-level program, and it's given the special indicator main. So an extremely common convention in Python programming is checking for that special identifier. And if and only if it is main running the body of your program. And what that means is we've been writing scripts so far where the body of our program is in the global namespace, and it's just a series of statements that executes. And if you import them, they run. But now when I import my script, nothing happens, which is probably what I want when I import. And if I want something to happen, I can specify it. When I run my script directly with the Python command, it does automatically run. So it is sensitive to the context it's being used in. Is it being imported as a library, in which case it probably better not do a bunch of stuff automatically? Or is it being run directly from the command line, in which case it probably had better run? And there's a bunch of other flags that we can do. We can do things like, if you're running this from the command line, run all the tests for my library, and otherwise do nothing. But this is the most common convention. Underscore name specifies the running context of the program, and if it's being used as a module, it'll contain the module name. Yep. Will I run as a top-level program, or am I being imported by other Python code? So it'll be the module name if it's imported, and it'll be main if it's being run directly. And in our case, all we care about is, am I being run directly or not? And I'd like all your scripts in the future to use this convention. And as we'll see, this lets us do a few other nice and nifty things. Right, so this gives us control over that. All of our code is happening within a function. The input point to our code is happening within a function instead of being top-level statements. And we're only calling that function, which I'm calling main, but I could have called whatever. The name is, again, not significant. We're only calling that function if I'm being run as a top-level program. So I'm controlling the execution of my program and saying, if you run me directly, let's run all my code. If you import me, let's let the importer decide what code to run. And it does mean that we can write things that function as full-blown scripts on their own, but other scripts can import them and use things like their data structures or functions and not get all the side effects of actually running the program. And that print there is kind of immaterial. What's significant is this statement here. This is a top-level statement. It's not inside of a function. And it's checking and seeing if my name is equal to main, then call a function. And else, there is no else. It doesn't do anything. So again, if I'm running directly, it runs. If I import it, nothing has happened. I get to explicitly specify what I want to have happen. And I wouldn't have to call main. If I had data structures in there, I could access them. Make sense? Yes, yes. So we're actually going to get there with our classmates file and add argument parsing to it today. But yeah, it is kind of common to say, I want to have a command line interface to this library that I'm creating with these functions that do some things. And I'll handle a bunch of command line arguments if I run it that way. And I also want to make it available to other programs to use my functions without worrying about kind of the main program logic. So yeah. And it's just a good idea. It means that you can import your code without side effects, which is polite to other programmers, which may be yourself. If your program, the first thing it does is delete the temporary file it's going to fill up. When you import it from another program, it may do some things that don't have any output that cause you trouble. So it's polite not to do anything whatsoever on import. And if you want to run things as a script, then hide them behind that if name equals main check. Nobody should ever import your module and all of a sudden say, hey, why is all this stuff happening? I just wanted to look at the help on this function. That's all I wanted to do, and all this stuff is happening. Yeah. OK, so we want to use this if name equals main, and I'm going to leave that piece of code up. The other thing we want to do that's it. OK, so our programs we have in their current state, we're going to change how they work. Go ahead and put your main program logic inside of a function. You can name it whatever, but again, main is kind of the convention, and it's coming from C days. If anybody ever wrote C programs, you have to have a main function. It's the default execution start. We're going to present a menu of user choices instead of soliciting input right away. So we need to handle the printing out the menu and handling the user's input for the menu. And then each of the things that the user chooses needs to work. And we already have all those working except for number 4, filter by role. And I'd like you to implement filtering by role with a loop and an if statement. So basically, loop through all the rows of classmates that you have. And any that have the right role, go ahead and keep. And when you've got a new list of students, a new list of classmates that have the correct role, you can pass them to your print rows function for output. So your list all function that prints all the records needs to be reusable. And then just for your own entertainment, do the same thing that I was doing. Be sure to import your script. Start Python, import, and let's call this one classmate7.py. And notice that nothing happens, which is what you want. And I should have demonstrated that as well. I can do dir on scripting. Scripting is just a variable that contains a module, and it has built-ins for the built-in namespace. __ doc. Anybody want to guess what that is? Docstring, exactly. I told you it was programmatically accessible. There's the docstring. The file, which is the file of the module, probably. The name, which we've already seen. Package, which we'll talk about in a while. And one local variable called main, which is the function that we defined. So you can introspect your script as a module and help nicely presents all that information. The name is scripting, where the file is, any local member variables, prints the docstring. So that last step is kind of just by way of exploration. And most of the work is going to be in number 2 and 3. So let's go ahead and get there. We can take a break. It's almost 10:15, so in 3 or 4 minutes we can go ahead and take a break. You can stretch as you like, but go ahead and start working on this. I'll kind of circulate and see where everybody is. I like to make sure everybody can complete this because, as usual, we're doing it a little bit the hard way, and then I'll show you some new tricks, and we'll do it the easy way.